Hi everyone, a very good morning to all. Today we are going to discuss about the dual nature of matter, nothing but de Broglie hypothesis. So every moving object associates with a wave. So that is what de Broglie said it, that every moving object has some wavelength. So every moving object is associated with some wave. So that means matter has particle nature as well as wave nature. That only dual nature of matter. And for that, he has given the equation that the wavelength of the particle is given by h by p, where p is linear momentum. That is what he said. Now when you consider generally what questions they will ask is, when you consider the de Broglie wavelength lambda equal to h by p or h by mv, if they give kinetic energy, then kinetic energy equal to p square by 2m implies p equal to root 2mk. This is the linear momentum. So linear momentum is under root 2mk. Then the de Broglie wavelength will become under h by root 2mk, so that lambda 1 by lambda 2 between two particles can be compared like k2 by k1, m2 by m1. Or if they give, if a charge accelerated through a potential difference V, then kinetic energy equal to QV equal to E into V if it is electron. So just Q into V. If it is electron, then only it is EV. So just let it be QV only. Then the lambda equal to h by root 2mk equal to h by root 2mqv. And in case of thermal neutron or gas molecule, when you consider lambda equal to h by root 3mkt, where kinetic energy equal to 3 by 2 kt, where k is Boltzmann constant, capital T is temperature. Now, finally, when you consider the de Broglie wavelength lambda equal to h by p or h by mv or h by root 2mk or h by root 2mqv or h by root of 3mkt. This is the final equation. Now let's see how the question will be asked based on these equations. The ratio of de Broglie wavelength of molecules of hydrogen and helium in two gas jars kept separately at temperatures of 27 degrees Celsius and 127 degrees Celsius. As it is thermal particle h by root of 3mkt, where m is mass. Now one is hydrogen and another one is helium. So that lambda for hydrogen by lambda for helium, when you take the ratio T helium by T hydrogen and mass of helium by mass of hydrogen. Now when you consider hydrogen, helium temperature is 127, so plus 273, you have to take in Kelvin always. So 400 by 300 times mass of helium is 4, mass of hydrogen is 2. So 2 2s are and 0 0 cancel. So root of 8 by 3. So this way you have to understand the question and you have to choose whether the formula to be in terms of temperature or potential difference or kinetic energy or linear momentum. Now, similar way, one more question is the de Broglie wavelength lambda associated with a proton changes by 25% if its momentum is changed by P naught. the initial momentum was. So lambda is inversely proportional to P. So that here lambda 1 by lambda 2 equal to P2 by P1, where the wavelength associated is changes by lambda 2 minus lambda 1 by lambda 1 into 100 is 25%. That means lambda 2 minus lambda 1 by lambda 1 equal to 1 by 4. So that lambda 2 by lambda 1 equal to 5 by 4. So this is what lambda to lambda 1 relation. Then P2 by P1 equal to lambda 1 by lambda 2, that is 4 by 5, implies P2 by P1 minus 1. If you subtract 1, minus 1 equal to minus 1 by 5. Now P2 minus P1 by P1 equal to minus 1 by 5. P2 minus P1 means delta P by P naught equal to minus 1 by 5. Then delta P means P final minus P initial equal to minus P naught by 5. So that P final equal to P naught minus P naught by 5. So P final equal to 4 P naught by 5. Oh, sorry, they're asking momentum is changed by P naught. That means delta P is P naught. Then they are asking the initial momentum is. So here, just see, simply you just take like this. Now delta P by P initial equal to minus 1 by 5. Delta P is P naught by P initial equal to magnitude, if you consider 1 by pi. So P initial will become 5 P naught. I think here options are wrong. So please correct it. Option should be 5 P naught according to the given question. So don't worry. So this is what they have given. Now, the next question is, the kinetic energy of an electron is 5 electron volt. Calculate the de Broglie wavelength. De Broglie wavelength associated is h by under root 2mk, where kinetic energy is 5 electron volt. 5 electron volt means 5 into 1.6 into 10 power minus 19 joules. That is what kinetic energy. So kinetic energy is this much. And mass of electron is 9.1 into 10 power minus 31 kg. Then lambda value h is 6.6 into 10 power minus 34 by under root 2 into 9.1 into 10 power minus 31. K is 5 into 1.6 into 10 power minus 19. So approximately try to take the values like here root 9, 3. So 2 5s are 10. 10 into 1.6, 16. Root 16 is 4. And 10 power minus 31 minus 19. So minus 50. So 10 power minus 25. So it will become approximately 2.2 by 4 means 0.55 into 10 power minus 9. So this is what in terms of meter. Then I can write it as 5.5 into 10 power minus 10 meter. Nothing but 5.5 angstroms. So this way, in this chapter, when you want to do the calculation, please try to take little approximation and try to do it so that you can save the time. So if the options are very close, then only you have to think about approximation. Otherwise, if you take approximation, then only you can do such big calculations. Not in this chapter, in any chapter. Now, the next thing is what is the momentum, speed and de Broglie wavelength of an electron with kinetic energy? So kinetic energy is 120 electron volt. Now first you convert it into joules, 1.6 into 10 power minus 19 joules. Then kinetic energy equal to P square by 2m, where mass is 9.1 into 10 power minus 31 kg. Then you will get the linear momentum. Just calculate it. Now, then they are asking speed. Speed means speed equal to linear momentum by mass. So after finding linear momentum, you just divide with mass. Then you will get the speed. And de Broglie wavelength means h by root of 2mk. Directly you can substitute, or else after finding p, you can take it like h by p, depending. So that way you have to solve it. But here if you look at it, if you understand the question, just formula and substitution and proper calculation is needed. Now one last and final question. For what kinetic energy of a neutron will the associated de Broglie wavelength will be? So it is neutron. So mass of neutron is 1.627 into 10 power minus 27 kg. Then lambda equal to h by root 2mk. On squaring both sides, lambda square equal to h square by 2mk. Then the kinetic energy will become h square by 2m lambda square. Now h means 6.6 into 10 power minus 34. So square is there, 2 times you take. Divided by 2 into mass is 1.627 into 10 power minus 27. Lambda square is 1.4 into 1.4 into 10 power minus 20 it will become. So now you have to take the approximate calculation, then you will get the kinetic energy. This value you will get it in terms of joules. Suppose if the option is given in terms of electron volt, so 1 joule equal to 1 by 1.6 into 10 power minus 19 electron volt. To convert from electron volt to joules, multiply with charge of electron. To convert from joule to electron volt, divide with charge of electron. And one more question is, also find the de Broglie wavelength of a neutron in thermal equilibrium with matter having an average kinetic energy 3 by 2 kT at 300 Kelvin. So they are asking at particular temperature. So lambda equal to h by root of 3m kT, where k is Boltzmann constant 1.38 into 10 power minus 23 joule per Kelvin, and temperature is 300 Kelvin. Again, the major or crucial thing is calculation. h, m, kt. All are big values, decimal values, 10 powers are there. So you have to take care of calculation properly. So this is how, when you look at de Broglie hypothesis, 99% questions all will come based on the calculation, a little big calculation, formula based questions. So please practice. Similar questions I have given as an assignment, then you will get the idea. And if you look at the NCERT questions, also lot of questions they have given. So please try to solve all the questions, NCERT based questions also. So thank you all. We'll continue in the coming session with the another question. Thank you.